So my name is Reinier I'm Dutch, but I moved to California 10 years ago. So if you hear a Dutch accent, that's where it's coming from. I'm home and I'm enjoying the rain outside. We could use some in California right now. Let me introduce myself. So I founded a company a year ago, and we help vineyards and farmers to use irrigation water more efficiently using precision irrigation, and we use open source technology for it. So all our technology, coding, circuit diagrams are available online for people who want to work with it, develop on it. We are based in Southern California in an area called Temecula Valley. Who has heard of Temecula wine country? Oh, wow, amazing. So that means that it's actually located here. Here's Los Angeles, here's San Diego. And the cool part of this is a wine area that is about 1 hour drive from both metropolitan areas. So we have a lot of people visiting us. Here's just a quick introduction for the people who don't know Temecula. It started... Audrey Salurzo and Vince Salurzo started their first winery in 1968, and as such, this wine country exists for 50 years this year, which is like a big celebration in our area. It's a warm climate. It's Southern California. We're close to the ocean, so in the mornings we have ocean breeze that cools down the area, and we have at this moment about 50 licensed wineries, and we have about 1.7 million visitors every year who come to taste our wine. You don't taste Temecula wines outside of our region because most of the wines are being consumed, bought off premises or consumed locally. So that's why you may not have heard of Temecula. Because it's Southern California, we have direct influence from the climate change, but we already had a kind of a warm climate. So we just had a wet winter last year, but before that we had a 5-year drought. So everybody is very aware of irrigation and the need to save water, or at least use water in an efficient way. Here's another data point that I wanted to share. It's not just that the climate is getting warmer, there's also more dynamics. So this is a data point from 2016, where we had 2 days where the temperature was actually pretty high. You can see the peak here for 2 days, and here you see what it did to the grapes. Basically, the grapevines started protecting themselves by selectively shutting off clusters. So we lost about 25% of our crop just because there was this 2-day heat wave. And this will happen more and more because we see these dynamics happening. As a group of growers, we got together. I own a vineyard, and we decided to do some extra irrigation when we see a forecast for getting heat waves. And we also leave now more leaves on the canopy. Usually we used leaf thinning in order to get wind through the vines, so you have less problems with mildew, but now we leave a little bit more protection so there's more shade. But this never happened before. So I'm talking to people who have been farming there for 40 years. They say, well, this never happened before. So there's something happening with the climate that basically makes us need to monitor what's going on. And sometimes you cannot prevent things from happening, but you can evaluate as a group and basically collect the data that you have collected and think about strategies how to cope with it for the next season. We have been optimizing irrigation, and the way we were doing it is this way. Here you see that the old way of irrigation used to be once a week, a big soak, and you see the water going deeper and deeper, and basically going beyond where the roots are. So every water drop that basically drains out of reach of the roots is being wasted. So what we've been doing now is we irrigate more frequently, and we put more sensors vertically in the soil, so we can see how deep the water goes and just manage the water to be within the active root system and not below. So there's actually one sensor here below, which is just below the active root sensor, which I call the drain sensor. I like to keep it dry, and that's a good indication that I'm not wasting water, and I keep the water in this area where the roots are actually taking up most of the water. So what did that bring me? I'm using my own vineyard as a test site. So if you happen to visit me, you see a lot of strange antennas and wires and stuff, which are not grapes, I can promise. But I use my own vineyard, and I also try to find where the limits are. How much can you save without losing your crop? So sometimes I get to the edge where I can do it, but you can see that we saved about 50% compared to years before. So here's 2 years before we used active monitoring, actively managing the irrigation versus what we did the last 2 years. So this was 2016 and 2017, so there's a 50% reduction of water. And of course, I'm a grower, so I get paid for the weight of the grapes that I sell. So I'm not interested in selling less grapes. So I try to save water without losing my crop. This is what the solution looks like. We developed our own sensors because the sensors that were available in the market were just too expensive. So we're looking at sensors that are $15 each as a target price, which is cheap compared to everything else that's out there in the market. And that means also that now these solutions are available that allow you to put multiple sensors in a vertical column and measure how deep the water goes, without crashing the bank. We have developed a sensor node, which you also can see on the LoRa Wall of Fame, as they call it. It's an Arduino-based system using a LoRa module to communicate. We put gateways on top of winery buildings in our valley, so we have full coverage. And we also built, with a European partner, an application that does more than just give you the sensor data. We thought that it was a better idea to give actionable data. Here's a quick story about if you want to look at agricultural solutions and you want to measure soil moisture. There's 2 types of sensors that you can use. There's this soil potential, and there is a frequency domain reflectometer, FDR in short. If you want to translate it in how do you measure it, on the left case here you measure the electric resistance of the sensor. In this case you measure the capacitance of the sensor. So sometimes you call it capacitive sensors versus soil matrix sensors. These sensors are freely available on the market, and they have different properties that make them more or less useful for agriculture. The capacitive sensors are pretty accurate in terms of the electric properties, but they are influenced by the type of soil that you place them in. So the calibration for these sensors needs to be done on site specific, which makes it kind of hard for the average farmer to calibrate. They are not very sensitive to salinity or temperature influence. And their major disadvantage is that they are soil sensitive, and the other advantage is that the range, where the actual soil volume that they measure is relatively small. So if you place a sensor like that in the ground, and there's a stone or there's an air pocket, that gives you a big influence on how the sensor performs. The other sensor, which is a resistive sensor, is my sensor of choice, to be honest. It's basically measuring the equivalent of soil water potential, which is a little different from soil moisture, but what it means actually is that it correlates with plant water stress. So basically this reading can be calibrated with other instruments that read how much water stress a plant actually has. And we found when we were measuring this in vineyards that the readings of these sensors correlate very closely with water stress measured by scientific equipment. But the most important thing is that they basically have they are independent of soil type, so that's an important thing. They have some disadvantages too. They have a significant temperature dependency, and if you have a gypsum-based type of sensor, gypsum slowly dissolves over time in water, so these sensors will need to be replaced over time. But the sensors that we developed don't have that. So this is, the soil water potential sensor is basically for farmers the the best sensor available. I was talking about open source and making this available to everybody who wants to work with this or develop with this. This is just an example of what is available online. So you see the schematic diagram. Oh, you see the schematic diagram, and you see also here a picture that explains what is all available. So there's a lot of openness. It's based on this little Arduino board here, and you see here the global set LoRa radio, and here the inputs for the soil sensors, and you see that there's also additional optional sensors available, like the digital temperature sensor connected to this one. It works with a solar panel, and we've been having units working continuously for 2 years now at this moment. So it's a proven platform. So while the hardware is in place now, we were also looking at what do you do with all that data? Initially, we started with dashboards that provide data, the sensor data, and we share that with beta testers. We have a group of about 140 growers that meet frequently. So when we're talking about the community, for example, this is a very tight, strong community, and that's what I liked about the Things Network, because they build community networks. And I got this idea that, hey, why don't we match that? Like, we built community networks for farm communities. That was my idea. Anyway, we started with 8 farmers 2 years ago. Now we have 140. We share not just this, but we share, like, how do you prune, how do you do pest management, and how do you fertilization, etc. So a lot of practical things in order to get the quality up of our grapes. Anyway, so part of that group is also an active beta testing group, giving me feedback about what they like, they don't like. We installed systems, and we provided them a dashboard that gave them gauges and charts. And they said, like, Reinier, what's this? So the sensor tells me the soil moisture is 70. What does that mean? Is that enough? Is that not enough? How much do we need to irrigate? So we needed to change the way we use the data, collect the data, and basically provide actionable information. So that's what we're doing right now. We've developed in collaboration with a company in Slovenia an application that basically does vineyard management. So it's not just irrigation, it's also work management, it's pest control. There's different modules, and one of the modules is irrigation. And this is what it does. So I hope it's readable, but basically it tells you, how long do you need to irrigate today? And it's based on a collection of data that is being opened. So we also are strong on open data. In California, you have a governmental organization called CIMIS, California Irrigation Management Service. They have a network of weather stations, very comprehensive network stations, and the data from these network services are available through an API which we can use. So you type in your zip code, your local postal code, and it gives you the local weather data. But more importantly, it gives you a unit which is called ET, evapotranspiration, which is a measurement about how much water is being lost each day. And it's calibrated for grass, so you need to compensate that for other crops that you have. But that's just calculation that you can do with an algorithm, so that's easy to do. But it basically is able to calculate very accurately how much water is being used by a vineyard. And if you want to keep the same moisture level, then basically on a daily level you need to replace the amount of water that is being lost. Some days are hot, some days are colder, so you see that amount of water that you need to irrigate fluctuate day by day. So that's what we're doing with this software. And this is basically what the farmers are using. Now they understand, right? We also looked at technology. So the way we approached technology is a little different. We are not a technology company. We were farming. And LoRaWAN or LoRaWAN happened by accident. It's like we needed a solution to measure how much moisture was in the soil. We needed to understand how do we use our water more efficiently for irrigation in our vineyards. And the technology solutions came as a result of that. So we're not a technology company looking for a problem to solve. We're having a problem and we're looking for technology. One of the problems that we wanted to solve, and we were looking at this problem for a couple of years ago, was, our first prototype used Wi-Fi, but the range was not enough. We got to the very edge of the vineyard, and then we barely could make a connection. So we tested that for a year, but we wanted to get to the critical spots in the vineyard. You want to have a choice where you place your sensors. So then we got in touch with a company that does LoRa modules, and as a result, we bought some development kits from them. And you can see here that we bought a GPS tracker with the LoRa module built in, and we had a gateway with an antenna. And here you see a part of the Temecula Valley where we have about 10 miles range, a line of sight range. This is from my vineyard, by the way. And this is my vineyard, and we basically, I attached this to the roof of my car and just drove around. So this tracker is reporting every 10 seconds, and you see every time I had a good connection, it gives me a little bar here. And this is the end of the wine area, so I didn't have to go further. But this is basically the coverage of one single gateway. This is about the whole wine area, by the way, and you can see there's some dead spots here because of hills. So we need to fill that up with other gateways. But other than that, we have pretty good coverage. Then the development. We're not good programmers. I can do some hardware programming, but a lot of the stuff that came with LoRaWAN was just too complex in the early days for us. We just wanted to have something that can transport data from point A to B. 5 miles range is enough. And I don't need all the complexity of LoRaWAN. And I talked with several manufacturers, and I asked them, like, can I do module-to-module communication, because that's the easiest. No, you cannot. You have a gateway and there's protocol, and I'll forget it. I'll look at somebody else. So we came up with a company that their name is GlobalSat. They're Taiwan-based, and actually they provide LoRa lower. How you say that? The lower networking layers of LoRa. It's called LoRaWAN. So it's basically you have a USB version, and you have a pin, a UART kind of version of the same module. So this is easy. I can make a gateway, plug this into a Raspberry Pi, have some Python code, have a gateway, great. And then this one goes into my nodes, and it's just powered, and there's a TX and RX pin. I put data in, and the data that I put in comes out of this USB serial port. Very simple, very easy to do. And for early development, this is a really quick turn to market. We still have this running. So we have several, I think we have about 50 of those nodes running. We have multiple gateways. One of the problems that we had was the gateways basically report to our cloud app, and in some cases the data was duplicated. But software can handle that quite easily. So that was how we started developing and what we did. Now we are implementing more complex, so we are growing in size, so we need to have better handling of larger number of stations. So we are starting to move in towards LoRaWAN. And currently we have 2 gateways active. A 3rd gateway was ordered and is on the way. And one of the reasons why we want to use LoRaWAN is the encryption. So a new development that we're doing is we're about to announce an irrigation valve controller. So instead of just telling a farmer, hey, you need to irrigate for 33 minutes today, go out to your vineyard, open the gate, open the valve, and come back 33 minutes later, it's not going to work. At least that was the experience last year when we did beta testing with it. So we noticed that there was a significant human error or human factor introduced in the irrigation accuracy. So by automating the irrigation control, we can take that away and actually execute accurately. The problem is when we were reading sensor data, that was not sensitive data. Anybody can read it. If you want to know what the soil moisture is in my vineyard, fine. But I don't want people to mess with my valves, my irrigation valves. So that's why we need to have the encrypted communication, and that's why LoRaWAN is such a good match. So we also are developing and announcing an orchard version of the application. So now we can manage irrigation in vineyards, and we can manage irrigation in orchards. And in California, we have a lot of pistachio and almond orchards, for example, as well as citrus. So with that, I hope I have given you an indication of what we did and our process to working with LoRaWAN, how we grew into it, why we did it, and some of the problems that we have encountered and how we solved it. So I'm open for questions.
Okay, we already have a question here.
Yeah. Thank you very much. It was quite interesting. One question with regard to the several Raspberry Pis you mentioned with the gateways.
Yes.
How are they connected to the internet? Are they with Wi-Fi connected, or do you have one central hub? How is that working?
Yeah, so the Raspberry Pi has two ways to connect to the internet. We standard use Wi-Fi, but in some cases we had wineries who had hidden Wi-Fi SSIDs, and we hooked them up using a cable, Ethernet cable.
That's a long cable then.
Yeah, and in all fairness, there was one winery that didn't have internet at all. Yeah. So we had this, I was scratching my head like, okay, how do we hook them up? But there was a gateway 5 miles away that, connected fine. So that's the point of, having a wide range, long range network. And you don't need to have a gateway for each and every winery. Although, if I give winery owners the choice, whether they want like a $350 gateway or waive the cost and share a gateway, they prefer to have their own. For some reason, they like to have their own and say, well, if my neighbor pulls the plug, the power, I still want to have local Wi-Fi access.
Okay, but then something I missed, because you just said previously when you started, you didn't have Wi-Fi coverage in all of your vineyard because on the end.
Yeah. The gateway is in the house, close to, and then the long range is covered by LoRa.
Okay.
Okay. Sorry. But,
okay. Oh, so many questions.
Yes, sir.
Hello. How do you? How far are the sensor in the ground?
How far?
You told the 3 sensor in vertical.
4.
4.
So we started with 5 feet, 4 feet, 3 feet, and 2 feet. That was too deep. And one of the problems, I don't know if you know, if you try to drill a hole of 5 feet, you start with a drill that is, I'm 5 feet 7, so it's like way beyond me. So we started experimenting with whether 4 feet was enough. So the story is about wine grapes, that they have very deep roots, and they have like 20 meters deep. It's just that the active water uptake only takes place between 2 and 3 feet in reality. And below 4 feet and lower, you basically are over-irrigating.
So do you have a sensor each 2 feet? 3 feet?
At this moment, so last year we experimented with 4 sensors. So 1 foot, 2 feet, 3 feet, 4 feet. The 1 foot sensor is kind of useless because there's no active root zone and it dries out too early because of evaporation. So for this year, my recommendation is 3 sensors at 2 feet, 3 feet, 4 feet for grapevines. For other crops, it's different.
Thank you.
Yeah, you're welcome.
Okay, so other people's.
Hello, from another Dutchman living in Spain, in my case, in a country with similar problems that you have mentioned here. My question is, are you going to make this a business? Are you going to sell your knowledge?
Oh, it is a business.
It is a business.
It is a business. And
okay.
One of the products is at the LoRa wall. You can see it. So the sensor station is available right now. And then the eVineyard application is available right now. And we will announce, so later this year, we will come out with the irrigation controller, which can control up to 5 valves, and the e-orchard software. So at this moment we have a full solution for vineyards.
Okay, thank you.
Hello. You said about having private gateways. Do you find that the farmers or the owners are prepared to share in terms of offering the service as a public service for the community as well as having their own private data rather than just having the private gateway?
Yes. It is a good question. So I think a farm community is interesting in the sense that they're all competitors because they're doing the same kind of business. Everybody's selling wine or selling grapes, but they stick together because we all have the same type of problems. We all face drought or pests or typical farming problems. If we can get an upgrade of quality of our product, better quality wine, better quality grapes. This is something that the whole community shares. We also have educational programs for free for farmers, for example, for growers, about how to improve the quality of your grapes. And as such, everybody is okay with sharing gateways. But I think it's a matter of protection. Once they become dependent of the data because they run their business using this application, they don't want to run the risk of their neighbor not activating or pulling the plug by accident of their gateway, and then they don't have access to their data. And actually that happened, like a cleaner lady is just pulling out the wall adapter and the gateway doesn't work, and then suddenly 5 wineries are out of data because we didn't have overlapping coverage. So for that reason, most of the farmers that I spoke with basically are pretty okay with like femtocell kind of gateways. And they're coming down in price anyway. I mean, they were like $500 last year, and now like I think there will be like $200 next year.
So from the photos that I saw in your slides, it looks like you did 2 things. The gateway looked like it had maybe a directional antenna, like the antenna was pointing towards the field. And then the sensor nodes were also looked to be elevated on some sort of pole.
Yes.
Was that your initial approach, or did you have to do that because you ran into signal strength issues?
No, we never run into signal issues, to my experience. And the largest range that we have is 6 miles. I do think that having an external antenna or an antenna that is different than the rubber ducky antennas that come standard, especially for the gateways, is a big advantage. We use the little rubber antennas for the nodes. Having them look above the canopy is just a matter of self-preservation because the vines grow fast, and if they're not way up, then the leaves will cover the solar panel, and eventually the system will die.
So
that's the reason.
It's more for the solar than
yes,
for the communication.
Yes.
Is having them up mounted up that high an issue for any machinery or workers?
Yes, it is. So we developed a system where we can quickly decouple the wiring from the sensors that are in the ground, because we have harvesting machines and they make meat short. The nodes would probably survive it, but I'm not willing to risk it, to be honest.
Okay.
So we take them down at harvest time.
Thank you.
Yes, you're welcome.
Other questions? Yep.
Sure, yeah.
Thank you. You show a sensor on the ground, but on the picture there is a sensor on the top. What does you measure with the sensor?
Sensor at the top.
It was the second or
the node is at the top. That's
exactly.
the electronics and the battery and everything. Yeah. And then wires go down into the ground, and that's where the sensors are.
Okay.
Yeah.
Have you had any issues with corrosion or electrolysis of your nodes, the resistive nodes within the cluster?
That's a good question. So that is a problem that that was the first problem when we started with the project. So we initially started with stainless steel electrodes, which work if you have the right type of stainless steel. We stick with that probably. We started with gold-plated electrodes, but they're not compatible with our cost target, to be honest. And the other thing is electrolysis around the electrodes, because if you apply a DC current to the electrodes, that sensor doesn't work. So we needed to have alternating current. So that's basically what we developed for this sensor type, that we have alternating current measurement circuits. So it's basically, we imitate an alternating current by rotating switching the polarity on the sensors. And we do that at 9 kilohertz. So we do it relatively fast, so you don't get gas production around the electrodes.
Okay, I think we're timed out, ladies and gentlemen.
Yeah, a lot of questions. Thank you so much.
Thank you very much.